Hey everyone! In today's video, we're diving into programming the 8085 microprocessor to add two 8-bit numbers and store the result in the appropriate locations. But before we get started, if you enjoy our content and want to stay updated with our latest videos, please like, share, and subscribe to our channel, iNet Tech Talk. This tutorial is especially for students pursuing degrees in electrical engineering, electronics and telecommunications, computer science and engineering, electronic instrumentation and engineering, and related fields. Let's get it done. Our goal is to develop an assembly language program for the 8085 microprocessor that adds two unsigned 8-bit numbers, produces an 8-bit sum, and stores any carry in memory in a separate location which is reserved for it. Let's take a look at the flow chart. It's always recommended to initialize at the start of any program. So, we'll load the initial address of the first 8-bit number into the HL register pair. To handle the carry after addition, we'll use register B, which is initially set to 00. Next, we'll transfer the first 8-bit number from memory to the accumulator using indirect register addressing mode. We'll then increment the content of the HL register pair to point to the address of the next 8-bit number. The content of the accumulator will be added to the memory content pointed to by the HL pair. We'll check for a carry. If there's a carry, we'll increment the content of register B by 1, otherwise, it remains 0. Finally, we'll store the result in the accumulator in memory as the sum and also store the content of register B in the next consecutive memory location as the carry. Let us follow the following procedure. It is very important to note that here we are considering memory locations E000 onwards for storing data, and we may use to write the operational codes, opcode, in separate memory locations. Programmers are advised to check the available user locations of memory for programming microprocessor 8085 trainer kits. Let us now understand the procedure. Store the data into the memory locations. Reserve the memory location E002 and E003 for storing sum and carry. Store the memory address E000 in HL pair. Transfer the content of the memory into the accumulator. Store 00H into B register to clear it. Increment the value of HL by 1 to make it E001. Content of HL will be treated as memory address and HL as pointer. Add the content of memory pointed by the HL pair and the content of accumulator. The result will be stored in the accumulator and flags will be affected. Addition gets reflected to accumulator and carry flags. Check carry flag status. If no carry, then increment the value of HL pair to E002. Store the content of accumulator to E002 location which was reserved for sum through HL pair. Increment HL content to E003 location which was reserved for carry. Store the content of register B to E003 location which was reserved for carry through HL pair. Let's now examine the second scenario where we add FF and 01, which will result in a carry. All the previous steps remain the same, except for when the carry flag is set. Please note that the initial procedures are the same. We'll start discussing the process after the addition is performed by the 8085 microprocessor. If there is a carry, the content of register B is incremented by 1 to reflect the carry. Following a similar procedure, we save the content of the accumulator to memory by incrementing the HL pair to point to location E002. Then, we save the content of register B by incrementing the HL pair to location E003, using the indirect register addressing mode. Let us see the algorithm. Store the data into the memory locations. Store the memory address E000 in HL pair. Transfer the content of the memory into the accumulator. Store 00 into B register to clear it. Increment the value of HL by 1 to make it E001. If we now use memory-related instruction, the content of HL will be treated as memory address and HL as pointer. Add the content of memory pointed by the HL pair and the content of accumulator. The result will be stored in the accumulator and flags will be affected. Check for carry. If there is a carry, then increment the content of register B with 1 to reflect the carry, else skip. Increment the content of HL by 1 to point E002. Store the sum in the accumulator to the memory location pointed by HL pair. Increment the content of HL by 1 to point E003. Store the content of the register B into the memory location pointed by HL pair. Stop. Let's examine the assembly language program. We'll begin at memory location F000, which is specific to the trainer kit being used. Programmers should refer to the user manual of the trainer kit to identify the exact range of memory space allocated as the user area for entering program code and operands. The instruction MVIB00 immediately loads the value 00 into register B. The opcode for MVIB is 06 in hexadecimal, which is stored at memory location F000. Subsequently, the value 00 is loaded into the next memory location. The instruction LXIH E000 loads 00 into the L register and E0 into the H register immediately. The opcode for LXIH is 21 in hexadecimal, which is stored at memory location F002. The value 00 is then loaded into memory location F003, followed by E0 in F004. It is customary to load the lower byte first and then the upper byte when entering the opcode and operands. The MOVA M instruction loads the content of the memory location pointed to by the HL pair, which was previously set to address E000, into the accumulator. The INXH instruction increments the content of the HL pair to E001. The add M instruction adds the content of the accumulator with the content of the memory location pointed to by the HL pair, which is E001. Again, the INXH instruction increments the content of the HL pair to E002. The JNC next, F00D, instruction jumps to the location labeled next, memory location F00D, if there is no carry. If there is a carry, the jump is not taken, and the next instruction, INRB, is executed, which increments the content of register B by 1 to reflect the carry. Next, the sum and carry are loaded into memory locations. The MOVM A instruction loads the content of the accumulator into the memory location pointed to by the HL pair, which is E002, reserved for storing the sum. The INXH instruction increments the content of the HL pair to E003. The MOVM B instruction stores the content of register B into the memory location E003, reserved for holding the carry. Finally, the HLT instruction halts the processor, indicating that all processes are complete. In conclusion, the Microprocessor 8085 program development involves several critical steps. The flowchart provided a visual representation of the process, ensuring clarity and systematic progression. The procedure to follow outlines the necessary steps to achieve the desired outcome, considering both scenarios where a carry is generated and where it is not. The algorithm offers a step-by-step guide, ensuring each stage is meticulously followed. Finally, the assembly language program, complete with operational codes and opcodes, translates the algorithm into executable instructions, demonstrating the practical application of theoretical concepts. This comprehensive approach ensures a thorough understanding and effective implementation of the 8085 microprocessor programming. Thank you for watching. If you found this video on programming the 8085 microprocessor helpful, make sure to check out our other tutorials for more in-depth content. Don't forget to like, share, and subscribe to our YouTube channel, iNet Tech Talk, for more exciting and educational videos. Stay tuned for more tech insights and happy learning.